This is the second in a series of videos in which I'm taking a brief look at this Riden RD6012 switching power supply. In the previous video I assembled this. I put it together from the various parts that I bought online. Total cost was around £100, and I thought what I'd do now is just compare it briefly with the 6006 that I'd shown in previous videos, and then we'll run it up to full power, see how it handles that, and how the internal temperature copes. And in the next video we'll look at some more detailed performance, so we'll hook a scope to it, but in this video I just want to run it through its paces, have a look at the menu and see how that compares with the 6006. So I've got the 6006 on top, the 6012 on the bottom here. Now the first thing to note is that I put both of these together using the parts that came in the various kits, and one thing that was notably absent in the 6012 kit that was in the 6006 kit was the fan controller and the fan itself. There wasn't a secondary fan. Now I had been led to believe that the switching supply had a temperature controlled fan, but when I assembled that turns out not to be the case. So if I now turn this unit on, the 6006 is turned on, completely silent. We've just got the heartbeat LED showing, but when I turn the 6012 on, you'll see the immediate difference. So fan's on all the time. It's a noisy fan, so I will have to modify this and put a fan speed controller in there. It doesn't need to be running the fan all the time. In fact, the 6006 doesn't use the fan that often. It's only when I'm running it up to full power. Now of course the 6012 does have twice the power output, so in theory it's going to make more use of the fan, but certainly when it's in standby like this, not doing anything, then the fan doesn't need to be running, and especially with it being such a noisy fan. So I've got it hooked up here to two Kunkin KP184s. I've got these connected in parallel because obviously each of these is only 400 watts, so with a peak output of 720 watts from the 6012, I'm using two of these side by side. I've got them both set to constant current mode. Again, I'm not going to do an in-depth review of the performance in this video. This is just to run it through its basic paces and see how it compares to the 6006. So as I said, noisy fan to start with. I think they should have kept the fan speed controller in the case kit. It does make a big difference, and even now with it set into standby, the fan still runs, and it is kind of a very annoying fan. It's probably not coming across that much on the camera microphone, but it is quite a loud fan. So we'll start off by comparing the boot up time, see how the 6006 compares to the 6012. So I'll start them both at the same time, and identical in terms of boot up time. So if we look through the menus and see how the menu compares, see if they've made any changes to the 6012 compared to the 6006. So if we go into the menu, then straight away we can see they are pretty much identical. I've obviously made a few setting changes on the 6006, but the 6012 is exactly as it came out of the box. So first thing I want to point out again, now I did get some comments on this in the previous videos, but I do feel obliged to point out what I think is a very poor feature, especially on the 6012. This thing can put out nearly 3/4 of a kilowatt, and because of the nature of the work I do, where a lot of the testing and development I do is on irreplaceable equipment, I would not use either one of these in the lab. They're good for high power when you need high power and for general experimentation, but I would not have these in the lab. And I'll demonstrate why. I'll turn the 6006 off and I'll demonstrate it just on the 6012. So when you have the general setting, it's fine. So this is how it comes out of the box. perfectly safe. And so if we select one of the memories, I'll go through the how to save the settings in a minute if you haven't seen one of these. But if we want to load one of the memories, then what we do is we press the shift and then the number of the memory we want to load. And it comes up with this little dialogue telling us what it's about to set. So voltage set 50 volts, current set 12.1 amps, over voltage protection 62 volts, and over current protection 12.2 amps. And this is what I have an issue with. This is why I think they need to change this, but I'll come back to what I mean by that in a few minutes. So we now have the option to say yes or no, so we can cancel this or accept it. If we accept it, then we end up with 50 volts at 12.1 amps. And if we want to select a different memory, then we can do that just by doing exactly the same thing. And if we want to change that, then we can just select a different memory, and that will enable us to load any setting that we want from any of the stored locations. Comes up with a warning each time. The output stays off, so that's fine. But why I have an issue with this particular setup and this system is if we go into the menu, the top two options we have here, where it's the worded take OK and take out, it's fairly vague. The manual does explain what they do, but if we change these two settings and then we exit the menu, as far as I'm concerned, this is now a very dangerous supply, not in terms of necessarily it killing you, but in terms of it destroying anything you're trying to work on. So currently we have 5 volts at 12.1 amps current limit. Over voltage protection is 62 volts, over current protection is 12.2 amps. But if I now select one of the other memory locations, it's now immediately loaded the setting and it's turned the output on. So we've now got 50 volts at 12 amps coming, potentially 12 amps coming out of this supply. There's no warning, and it just immediately turned the output on. I think that's a bad feature, and if you want this feature, then you might find it useful. Some people say they like it because it cuts down the number of key presses. Well, it doesn't cut down the number of key presses. You can do exactly the same thing with the same number of key presses. Other people say they like it because they like to be able to ramp the voltage up and down to do various testing. Well, again, no, you don't need this. If you select the voltage, if you want to go up and down in 1 volt steps, you can just use the encoder. There's absolutely no reason to have this particular feature. If you like it, all well and good, but I think the risks far outweigh the benefits of having that. Now, if they really did want this feature, then I think they could implement it in a better way. And the reason I think this is implemented so badly, let's say we want to save a particular setting. So we'll go to overcurrent protection. So we'll set the overcurrent protection at 1 amp. And we'll set the over voltage protection at, we'll say 6 volts. Let's say we're working on a 5 volt system, and that's the absolute limit that we want. And so we'll set the voltage now to 5 volts, and we'll set the current to 1 amp. And then we can now save this to whichever memory location we want. So I'll save it to memory location 2. And so anytime we want to come in here and re-establish those settings, we can just select memory location 2. The reason I think this is badly designed is I believe that the over voltage protection and over current protection should be completely separate. I don't think they should be retained with the memory settings, because otherwise they are totally pointless. There is no point having over voltage protection and over current protection that is automatically loaded when you change memory settings. So for example, we currently have over voltage at 6 volts, over current at 1 amp. So let's say I now inadvertently select the wrong memory location, then what's going to happen is it's going to, as it has done here, it's loaded 50 volts at 12 amps. Over voltage protection has been reset to 62 volts and the overcurrent at 12 amps, and that was just 2 key presses. So if I accidentally press the wrong 2 keys, bear in mind if you're working, at the moment we're focusing on just this, but if we're working and we're getting distracted, mine's somewhere else, and we want to just change the setting on here and we accidentally press the wrong option, the wrong key, then we've just completely destroyed what could be a priceless piece of electronics. This can put out nearly 3/4 of a kilowatt, so allowing that to be instantly put through anything is, I think, a bad design. What they should do is have over voltage protection and over current protection as completely separate settings that override the requests for memory loading. If they did that, then the feature would be safe. What you could do is just make sure that's set at the beginning of the session, but as it is now, it's extremely easy to inadvertently, with just 2 key presses, go from 5 volts at 1 amp maximum up to a 720 watt output, 60 volts at 12 amps, and that would destroy anything it's connected to. So that's my only gripe with this. I've banged on about it enough now. If you like the feature, all well and good, but as I say, I don't believe it's necessary. If you want to be able to ramp voltages up and down, just go to current voltage set, and then you can use the encoder. Same with the current, there's no need for the feature, but if you like it, that's I think a personal preference. So what I'll do now is just quickly compare the menu system on the 6006 to the 6012. So if you have the 6006, we'll see how it differs from the new unit. Okay, so we'll go into the menu on both of them, and you can see that all the settings are identical. There's no difference whatsoever in the actual settings. I have changed some, of course, but in terms of what's available, they are identical. We'll go on to the next screen, and again they're identical as well, as are the next screen settings, and the only thing that's different, of course, is the version, model number and firmware. So as you can see, if you're familiar with the 6006, then the 6012 it only differs in its maximum current, and the voltage limit is the same. Okay, so what we'll do now is give the 6012 a full power test and see how it performs. I've got it hooked up to the 2 KP184s. These are both set to constant current mode, so we'll turn those on. We'll set the Riden to a good starting point, and I'll set it to, I'll leave it at 12 amps, it's already set to maximum current. But we'll change the voltage to 5 volts, and then we'll turn this on, and as we can see, we're getting 5 volts. We will get some voltage drop in the cables, of course, but bear in mind what we have to do here is combine the 2 power outputs to give us the total that the power supply is putting out. These are of course splitting the load, and I have to do that because each one can only take 400 watts maximum. Okay, so it's looking fine so far. I'll increase the voltage on the power supply, and as we can see, that's ramped up nicely, it's nice and stable, and we are getting quite a nice stable output from the supply. So I'll now ramp the supply right up to its maximum voltage, 60 volts. And we can see that we're now getting 60 watts out of each electronic load, so a total of 120, which more or less matches what's on the Riden. And what we'll do now is we'll start to increase the current that is being drawn from the electronic load, so we'll go up to a total of 4 amps. So we're putting out just under 240 watts. Just under 4 amps and 60 volts. and we can see the input voltage. This is the output voltage of the internal switching supply, is currently at 69.7 volts, so that's quite nice. It hasn't really drooped very much. So we'll go up to a total of 6 amps. So 6 amps output, 360 watts. So this is of course where the 6006 would max out. That's the maximum output for this unit, but we're only halfway to the maximum output of the 6012. Switch mode supply is down to just very slightly under 69.7 volts. Everything else seems fine. The internal temperature is still around 25 centigrade. I've noticed quite a lot of noise on the reading for this temperature, which I didn't see on the 6006. It's not too bad, but it does tend to fluctuate over 1 or 2 degrees. It doesn't really matter, it's not meant to be ultra precise, but it would be nice if that was filtered a bit more. You can change the update rate by the way of the screen, and I'm assuming that will change the update rate of the temperature display as well. Okay, so we'll go up to 8 amps. So we're now at 480 watts. All looking stable, still up at 69.6 volts on the switching supply, and the temperature is starting to climb. It's at 27 degrees now. Fan is going of course all the time, so that's going to help keep the temperature down, but I will show this test again once I've got the temperature control fan in there and see how quickly the internal temperature ramps up. Okay, we'll go up to 10 amps total. So we're now just on 600 watts out of the Riden supply. Now, this is a huge amount of power for such a small supply, so this is quite impressive. If you want a small footprint supply that's capable of putting out a lot of power, then this unit will certainly meet that target. Okay, we'll go up to the full 12 amps. And we're now at just under 720 watts total output power, 12 amps, 60 volts, and the switch mode voltage is now down to 69.46 volts. So it's only dropped by about half a volt, which is extremely good. And what I'll do is leave this running for a while and we'll see how hot it gets. Okay, it's been going for about an hour now. You can probably hear that the internal RD6012 fan has kicked in, so there is another fan on the actual 6012 controller as well as the case fan. That's kicked in as well. It's not really surprising. Internal temperature's got up to about 45 degrees, 46 degrees centigrade. Most of this noise is coming from the Cunkins. Obviously these are just dumping power and they're both nearly maxed out, so there is a lot of heat coming out of these. And the actual Riden itself is fairly cool still. It's not blowing out much hot air from the back, and considering it's sitting right alongside these units which are pumping out a lot of hot air, then it's doing extremely well. So it's just down to 47. And I'll leave it going for another hour or so, but it certainly seems to be able to handle this power well for extended periods. As I say, I'll give it another hour, and if nothing destroys itself, then okay, it seems to have had a bit of an issue. It's shut itself down. I'm not sure what's going on there. Quite possibly, I think what may be happening here is the switching supply may be struggling to keep going at the output power. So that's quite interesting. It looks like what may have happened here is the internal switching supply has overloaded and shut itself down. So I'll open this up. Okay, so the failure is in the switch mode supply. It's I think the output pass device has failed. I think it's gone short circuit, and it's no longer outputting anything significant. It's about half a volt or something. So I don't think it's the Riden unit. I'll test this separately, but the switch mode supply has definitely failed. It's not that surprising, although this is the supply they specify with the kit. It's only rated to 11.4 amps, which obviously when we're trying to pull 12 amps from it is not enough. Now, nothing got particularly hot. We only got up to just under 50 degrees, and that was the hottest part, which is this device, which I determined using a thermal camera. And so it wasn't a cooling issue. I think it's just it cannot handle the amount of current that we're trying to pull from it, although strangely none of the internal fuses have blown. So it's, I think, typical of cheap supplies. They don't really perform quite as well as you'd really like them to. So what I'll probably do is have a look at the supply and try and figure out exactly what the mode of failure was. If it is just the output pass transistor, pass device that's failed, I might have a look to see if there's a higher rated version I can put in there, but otherwise most likely I'll find a higher rated switching supply. So just be warned that if you do use the supply that comes with the kit, and in this case that is the S870, it's obviously not going to survive if you leave it running for a long time at the maximum output, which is what I did. As I said, it didn't get particularly hot, but obviously it's just I don't know, over spiked in current or something, and just stopped working. So what I will do is investigate this and let you know exactly what I find. In the meantime, we'll just do a quick test on the Riden unit to make sure that's still working, and all being equal, I'll find a better spec supply and we'll try this again. I've got the Riden hooked up to the bench supply and we'll see if that still works. And so as we can see, that still seems to be fine. So the Riden's survived. It seems to have handled the high output without any problems, but we need to find a better switching supply for the back end. So just be warned, if you do buy this kit and you have this particular switch mode supply, then you might want to limit the output to maybe 10 amps. But what I'll do is I'll try and find a supply that will handle this for an extended period, and then if I can find one that works, I'll let you know the type that I found. Okay, so I've had a look at this power supply to try and figure out what the mode of failure was, and it's actually the steering diode that's gone short. It's a dual diode and one side's gone dead short. And I did have some of these. If you're interested, it's an MUR 3060 CT, so it's 30 amp dual diode, 600 volt. But I've seen these in other circuits and they're actually quite slow in switching, so they tend to get fairly hot. Now, this is the heatsink that the thermistor on the Riden was sitting on. So looking back at the video, I noticed that just before the failure, the temperature started to rise very quickly. It had been sitting at a fairly steady temperature of about 44-45 degrees for nearly an hour. But just before the failure, it shot up to at least 50, possibly higher. And I think it was this device that was failing, and there was no sign that it was overheating previously. But I tried another device in. I've taken this apart, of course, taken the heat sinks off, and I fitted a replacement device in the same position. And I put a scope across it and looked at it, and the signals looked terrible. It wasn't switching properly, and this is the diode that switches the inductor to ground as part of the switching circuit. So looking at that, there's a lot of ringing, a very dirty type of switching, so that's possibly it exceeded the 30 amp limit for the peak current. And so I've got a higher current device in here just for test purposes to see if it will work. And in theory it should. I've tested all the other parts and they seem to be intact. The main switching devices seem to be fine. So what I'll do is I'll try and power this up and see if we get any output voltage, and if we do, then I'll get an even higher rated dual diode and then reassemble this, and in the next video run it up. But first I want to see if this does actually cure the fault. Hopefully you can see the meter there. So I'll power up the switch mode supply, and sure enough we're getting the output voltage again. I won't leave it on too long. Also, there's no heat sinks in any of these, and they will tend to get hot fairly quickly. It appears the fan is temperature controlled, but it's kind of on and then really on. It just goes very fast once the temperature starts to climb. And again, that seemed to come on a minute or so before the failure, but it seems the switch is on about 42, 43 degrees, so it certainly wasn't a thermal issue. I'm pretty sure it was just overcurrent spike at the very high output, possibly because we were pulling 12 amps out of this rather than the 11.4 amps it's rated at. So as I said, I'll get a suitable device fitted. I'm not going to fit the same type again. I'm going to fit an uprated device, and then I'll run it back up to full power in the next video and see if we can make any progress on being able to run it at the full 720 watts continuously. And so if you do have one of these kits and you've got this type of supply, just be a bit cautious running it at full power for extended periods of time.